solve the inequality. 8x plus 10 is less than or equal to 2 times the quantity 3x plus 11. Now, this is an inequality. We treat inequalities, we solve inequalities with most of the same steps that we solve equations by. And one of those that we would start off with, of course, is to apply the order of operations to simplify expressions on both sides. So I see that we have parentheses here. The expression in the parentheses contains two unlike terms that cannot be combined with addition. So we apply the distributive property of multiplication. Multiplication distributes across addition. So we are going to remove the parentheses via the distributive property of multiplication. So this 2 is going to multiply this positive 3x. Signs first. Positive times positive makes positive. 2 times 3 makes 6. And then here's the x. So signs, numbers, and variables. Then we distribute the 2 to this. We treat it like a positive 11. Positive times positive makes positive. 2 times 11 makes 22. So I think we've simplified the right side as much as possible, being that addition is the only arithmetic operation on the left side, and this 8x term is unlike the constant term of 10, then both sides have been simplified as much as possible. Now, here's where another similarity lies. Our goal for solving this inequality would be positive 1x is less than or equal to a number, or we could have the x, positive 1x, on the right side, being that, and a number on the left side, being that we have x terms on both sides of this inequality, the possibility exists to go into either side with the x terms and the numbers to their opposing side. There's one other issue with inequalities, that the one issue that differentiates them is that if we ever had to multiply or divide by a negative number, this is like the major difference, the one major difference in the solving process, is the inequality symbol that we start with, this less than or equal to, could flip to greater than or equal to in either of these instances. If we had to multiply or divide the inequality by a negative number. That's a big consideration, and it differentiates inequality solving from equation solving. So let's get there when we get there. What I see at this point is, let's decide which side to send the x's. I say that if we subtracted 8x from both sides, if we eliminated the x, made it a 0 on the left side, and then balanced the equation by subtracting 8x from the right side, we would be left with a negative 2x. Perhaps we can avoid this flipping of the signs altogether if we subtract 6x, eliminate it from the right side of this inequality, from the right side, and balance the inequality by subtracting 6x from the left side. See, when we subtract the smaller of the two x terms, we are left with a positive coefficient for x. That just makes things a little bit easier when we're solving inequalities because of this flipping issue. Now, because we subtracted, subtraction and addition never changed the sense of the inequality. This is still sensing less than. But let's bring down all the characters, all the math symbols that we haven't touched yet, and re-simplify. 0 plus 22 is 22 is less than, okay, and then we have 2x plus 10 is less than or equal to 22. Now, we've moved all the x terms to the left side. Now we want to make sure to move all the constant terms to the right side. So we're going to target this 10, target it for elimination from the left side. Use 10 against itself. Now, 10 is involved in addition. Only addition and subtraction are compatible for an operation like this. So if I had to add 10 to make 0 or subtract 10 from positive 10, I'm definitely going to subtract. Positive 10 minus 10 makes 0. Let's balance the equation out by doing the same thing to the right side. 2 minus 0 is 2. 2 minus 1 is 1. Less than or equals 2 symbol is still running down between these. We're going to bring down the 2x, and it doesn't matter whether we say plus 0 or minus 0. We have 2x is less than or equal to 12. In the very last step of solving this inequality, the only last remaining component that we need to make happen is we need to make the coefficient to the left of the variable become a positive 1. Right now, it's a positive 2. The 2 and the x are connected together with multiply. So the reverse operation of multiply is division. It's one way to think about this. Take the 2 and divide by itself so that we generate a positive 1x. Any number divides into itself once. It leaves ones behind. But the consequence is that we have to balance the equation and divide the right side also by 2. Now, since we're dividing by a positive number, positive 2, there is no need to flip this inequality to sense greater than. It stays sensing less than or equal to, so we just simplify. The 12 divided by 2 is 6. Now, let's come up here to our working area. What we've achieved is x is less than or equal to 6. We're being asked to show the solution set, and I can tell you that if all we did was add these symbols, the set of all real numbers x such that x is less than or equal to 6, that's enough to find the solution either in A, this looks correct, less than or equal to 6. Really, I mean, if we feel good about our answer, we would be done. But let me show you how, because it's the only answer of the choices shown that has this solution set shown. I'll bet you the answer is going to be A. But here's the consideration for graphing an inequality that has a two-part inequality symbol, less than or equal to, and that is, what numbers could we put in for x that would be less than or equal to 6? This is really a two-part question. So when we are looking at a range of numbers, because it seems to me that there could be numerous numbers, a numerous supply of numbers that could fit this these criteria. If I start with here is the number 6, and let's look at a number to the left of 6 and a number to the right of 6, and we'll gradually put these in here and see what turns out true or not. Because remember, any number that you put in place of the variable into an equation or an inequality and arrive at a true statement, well, that number is a solution, and it would get marked, graphed on the graph as how to build one of these graphs that are shown. So if I start with the number 5, let's put the 5 up in this parentheses in place of x. I would ask these questions. Is 5 less than or equal to 6? Now, here's the issue. Is 5 less than 6? Is that true? Yes. 5 is less than 6. That's true. Is 5 equal to 6? True or false? Well, this is false. But because we read this as less than or equal to, only one of these has to be true to consider this whole thing true. True or false. This is true. 5 is less than 6. So we do consider 5 a solution. If we continue this, like the number 4, if we put the number 4 in this parentheses in place of x, is 4 less than or equal to 6? Yes, because it's less than 6. 4 is less than 6. Even though 4 is not equal to 6, this part will be false, but this part's true. So this is what starts building a range of numbers to the left of the number 6. All of these numbers get graphed, and it's what forms what we call shading of the number line for multiple numbers, and it just keeps going. It crosses over 0 into negative territory to the left of 0. Now the question is, how about this? If we start a new set of parentheses, just so we have a clear idea here. What if we put 7 in? Let's try 7. Is 7 less than 6? Is 7 less than 6? Would that be true? No. That's false. Is 7 equal to 6? These are the two parts of the less than or equal to. Is 7 equal to 6? No, that's also false. So when we get two falses from less than or equal to testing, 7 we find out the whole thing is false. 7 is not, it doesn't make any part of this compound symbol true. So none of the solutions are on the right side. The last test that we need to make is 6 less than or equal to 6? The actual boundary number, the number 6 in this equation. So we would say, is 6 less than 6? True or false? That's false. A number cannot be less than itself. But is 6 equal to 6? Well, yes, that's true. So because one of these two parts is true, we hold all of the 6's less than or equal to 6 as true. And the way we show that 6 is a solution is we show a filled in circle. We call it a closed circle. So what 6 represents is the end of shading. It's the last number that in this progression, or the first number is however you want to look at it. It's the first number going down towards 0 that would be indicated as a solution. So here's, and every single number to the left of that's less than 6 would also be a solution. So here's that graph, a closed circle at 6, shading that goes on forever in the direction of negative numbers, and the set of all real numbers x such that x is less than or equal to 6. So the correct response to this, if it was a multiple choice test or exam, would be A.